So, after the nitrogen and carbon cycle, now it is the turn for us to go for the next most important biogeochemical cycle prevalent in our nature, that is oxygen cycle. So children, when we talk about oxygen cycle, we should keep in your mind that oxygen exists in atmosphere in diatomic form. Diatomic. Di means two, atom is atom. So when oxygen is present in two atomic state, we will call it as diatomic state. So as you can see here, I have written oxygen cycle O2. So you can say that it is present in diatomic state. So in atmosphere, oxygen is present in diatomic state. It constitutes of 21% of the atmospheric gases. Constitutes of 21% of the atmospheric gases. It is also found in combined state. Except from being in elemental diatomic form, it is also found in combined state in the form of CO2, that is carbon dioxide, or H2O, that is water. So CO2 and H2O are the combined state of oxygen. CO2 and H2O. So what are the main places where there is use of oxygen? Well, oxygen is used in making the biomolecules for our body. Starting from carbohydrate, protein, lipids, all the major biomolecules required the presence of oxygen as one of the imperative element in it. First. Second is, oxygen is required for our respiration. As we all know, we take in oxygen and give out carbon dioxide. So oxygen is required for us to be living. Third, oxygen is used in making oxides of many compounds like carbon dioxide 1, sulfur dioxide. So oxides of many elements, there is use of oxygen. Also, oxygen is used or found in nature in the form of carbonates, in the form of nitrates, in the form of sulfates. So oxygen, apart from being in elemental O2 form, can be found in combined state as in CO2 and H2O. Also, it can be found in the form of oxides of various elements. Also along with that, it can be found in the form of carbonates, sulfates, nitrates, and so on and on. Now let us move into the oxygen cycle. It is very easy. Please try to concentrate. The atmospheric O2, that is atmospheric oxygen, is being used by the process of respiration. Here I have marked the chemical formula for respiration, that is C6H12O6 in the presence of oxygen breaks down into CO2 and H2O. This is the chemical equation for respiration. So you can see O2 is being used. So in respiration, O2 is used. This process is now continued as water. See, water is released after respiration, so in the form of water, and then this water is used in the process of photosynthesis. We all know photosynthesis is the process by which green plants make their own food. So I have marked that reaction also. See, carbon dioxide plus water in presence of light produces glucose, oxygen and energy. This is the chemical equation for photosynthesis. Okay, so what I started with? We started with atmospheric oxygen, which was used by respiration, and after respiration is over, we release water. This water is now used by photosynthesis, and after photosynthesis is over, again that oxygen is released to atmosphere. As you can see, oxygen is again released. So the oxygen goes back again to the atmosphere. So children, it's very clear that there is a cycle. It started with atmospheric oxygen and again ended with atmospheric oxygen. What is another way of using atmospheric oxygen? Organic molecules like glucose. What is the chemical formula for glucose? C6H12O6 is the chemical formula for glucose. It is one of the carbohydrate, as we know. So this glucose is now undergoing the process of breakdown by means of respiration. So as I have already mentioned, This is the chemical equation for respiration. So glucose has been broken down. So by the process of respiration it is broken down, and what is it released? It released carbon dioxide. See, it is releasing carbon dioxide, and this carbon dioxide is now used in the process of photosynthesis. See, it is used in the process of photosynthesis, and finally through photosynthesis what is formed again? Again organic molecules like glucose is formed, and organic molecules like glucose is formed in the cycle. So this is very easy. What we started is, we started with atmospheric oxygen. In the process of respiration it is used. The byproduct is water. The water is used by photosynthesis, and again oxygen is released to atmosphere. Similarly, organic molecules like glucose, which has a huge number of oxygen, see 6 oxygen is present, is broken down by respiration. It is being broken down by respiration, and it is giving out carbon dioxide and water. It is giving out carbon dioxide. This carbon dioxide is used in photosynthesis. This carbon dioxide is used in photosynthesis, and again organic molecules like glucose is formed. Organic molecules like glucose is formed. So this is all about the oxygen cycle. So there are 3 processes by which oxygen is mainly utilized in our earth. One is respiration, another one is combustion, and another one is making of oxides of nitrogen. So what are the 3 things? Let's talk again. We have discussed respiration is one process. We have seen that. Combustion means burning of some fuel in presence of oxygen. So combustion, oxygen is very required. We have already done many experiments with candles extinguished in absence of oxygen, and oxygen is used for the process of making nitrogen oxides. Also, oxygen is given back to the atmosphere by only one process, and that process is photosynthesis. As you can see, oxygen is given out. Okay, this is a non-balanced equation. You can balance and find that 6 molecules of oxygen, 6 O2, are released when the photosynthesis process occurs. Okay, so this is all about the oxygen cycle. So let us move to the last topic of this chapter, that is ozone layer and its depletion. Now, the last topic of this chapter is ozone layer and its depletion. What we have learned just now is that oxygen is present in the form of diatomic molecule, that is O2. But upon going to the levels of atmosphere, as we have discussed in the initial parts of the chapter, it was found that oxygen is formed in a triatomic condition. Like 3 oxygen atoms are combined with each other, and they form what is called O3 or ozone. As you can see here, ozone or O3. It is a triatomic molecule because 3 oxygen atoms are attached to it. Ozone is very stable and it cannot be broken down very easily because of the chemical bonds persisting in it. But the major portion or major contribution that ozone plays in our life is it absorbs the ultraviolet or UV radiations that comes with the solar radiation to the Earth's surface. Mind it, triatomic ozone or ozone molecule as such is very poisonous, and that is why it is not reacting so easily with any other molecules in our atmosphere. But it is present, like if it is the Earth, then it is present like this, covering the Earth. Okay, if it is Earth, then ozone is present covering the Earth. See, I have written here, ozone forms the outer covering of Earth. So the ozone layer in the upper reaches of atmosphere forms the outer covering of the Earth. Now what is that so special about ozone? That also I told you that ozone absorbs the UV radiation that is coming from the sun with the incoming solar radiation. It absorbs UV light from the sun. Clear? Now what if the UV light is not absorbed? I can ask that sunlight is coming, we are happily accepting that. Then what is the problem with ultraviolet or UV light? We have a visible spectrum of light. You know that, VIBGYOR, isn't it? Violet, indigo, blue, green, yellow, orange, red. VIBGYOR. This is the visible spectrum of our light. Light falling from this to this region is what we can see, the wavelength. You know that. Ultraviolet light lies below the visible spectrum of light. That is, we cannot see the ultraviolet light. Okay, it lies below the visible spectrum of light. And what it causes is, it causes skin burn and skin cancer at last. UV light or ultraviolet light coming from the sun when falls on our skin falls on my skin, then it can cause skin burn and melanoma, that is skin cancer, melanoma at large. So that is why you can conclude that ozone layer is so imperative in our nature. You can have this question in your examination, what is the importance of having ozone layer? Then you shall write all these points. Now what is the concern about its depletion? It started from 1980 when there was a hole spotted in the ozone layer. And definitely a hole means it shall allow the UV light to pass through it because there is no ozone to absorb that. So in 1980 a hole was observed in satellite image over Antarctica that UV light is coming through that hole. 1985 the hole largens and 1990 the hole is more large. So day by day the hole in the ozone layer is getting large and large. What is that which is causing the hole in the ozone layer? Well, we all prefer to stay in the air conditions of our home having cool and calm atmosphere. We shall all love to have the ice cream out from the refrigerator and enjoy the cold, wonderful dessert as such. But in disguise, we are destroying our ozone. How? Because air conditioners and refrigerator and many other equipments that we use from day-to-day life release CFC, whose full form is chlorofluorocarbons. Chlorofluorocarbons means there is chlorine, there is fluorine attached to carbon atom. And this chlorine and fluorine are very stable and do not degrade easily. Upon reaching to that ozone layer, it starts to react with ozone, forming hole over there. So the CFCs released from air conditioners or refrigerators react with the ozone to form hole in the ozone layer, allowing the UV light to pass through it and cause skin burn and skin cancer like diseases. So not only CFCs, severe air pollution also results from CFC, which is responsible for the hole in the ozone layer. So in one way, the one component that is responsible for the whole of ozone layer is CFC. So it is our utmost duty or responsibility as a whole to shoulder this novel activity and not allow large amount of CFCs to release in our atmosphere, or else that day is not far enough when the entire ozone layer will be depleted and we shall all be the victim of diseases like that of skin cancer. So with this we end this chapter, that is natural resources.